This is chapter 6.1, finding the margin of error. And what you're going to do is you're going to be given three values, C, S, and N. And even though this formula doesn't use S, because when your sample is over 30, you can always replace the sigma with the value for S, because this is just the population value, S is just the sample value. So the first thing I want is I want a critical value, and I'm going to have a sample, and then I'm going to have an N, and that's the number of entries. And in the problem I'm going to look at, the C is equal to 0.975, so we need to find a critical value, and I'll tell you how to do that in just a minute. The sigma is going to be the sample, which is 4.6, and the sample size is N equals 100. So the first thing I'm going to need to do is, the table in the back of the book shows only part of the curve that's in the normal part. So if the value I'm looking at, C, is 0.75, I need to subtract that from one whole, and I'll get 0.025, and then because that's just the part that's under the curve, I need the two tails. So if I divide that number by 2, that tells me that each tail is 0.0125. So what you do with that is you take that number 0.0125 and you look it up in the table in the back of the book, table 4, which is the normal distribution, standard normal distribution. And I try and find the closest number to this, and I think this one was actually in the back of the book. If the actual number's not there, you look to see which one's closest to it, or either you average the two of them, the two numbers that it's in between. So you look on the inside of the table and find this number, and follow the number and get the number off the left side and the number at the top above this number inside of the table. I maybe should have shown you that, but if you don't know how to use the table, just let me know and I'll send a video for that. But anyway, what you find out is to the left of that number you'll get 2.2, and above that number it says 0.04, and if I add the two of those together I'm going to get 2.24. So what I'll do, that's my critical value now, and so I'm going to sub in the formula, and there's the formula again. So I have 2.24 times 4.6 divided by the square root of 100, which is 10. And so I'll work this out, and I'm going to get 1.03 as my margin of error.